Hello friends, welcome to my channel. My name is Sahal Basani. I am a lean management consultant, an ISO consultant, Six Sigma consultant, and not forgetting an ERP consultant as well. On my channel, I will be giving you a lot of knowledge on the different concepts which are linked directly to these topics, and I know you want to find out what exactly these different topics are. I will be leaving you different topics every week, and I'll make sure to post one video weekly. So make sure you subscribe to my channel, and if you really like the video, please leave a thumbs up or you can share the video to show your support. Now let's get right into it. The first topic we're going to be talking about is called Statistical Process Control. And this is the introduction video. Remember, I have two more videos of the Statistical Process Control. But first, let's dive into what exactly is Statistical Process Control and where does it derive from? So we have five core tools in quality. The first one is APQP. Obviously, I will be posting some videos on APQP in the future, so make sure you subscribe to my channel to know exactly when I will be dropping videos on these particular topics. APQP is Advanced Product Quality Planning. PPAP is Production Part Approval Process. MSA is Measurement System Analysis. SPC, obviously Statistical Process Control. FMEA, failure modes and effects analysis. So these are the five core tools which we have in quality, and these are very important for any quality assurance manager or any manager who wants to go into a production facility must know these methods of measuring your quality, and it's very important because you will be using a lot of these systems and they're all interlinked in within each other. But make sure you leave subscribe so that you know exactly when we are going to be posting the next videos. So let's start with what is statistical process control. You might be wondering what exactly it is, and let's dive right into it. So use of statistical controls to control a process or production method. It monitors process behavior and finds solutions for production issues. Now, this has a lot to do with your manufacturing plant, so please keep in mind these points, they're very important. It ensures the process operates efficiently and reduces NC with less waste. Now, NC is a very important topic. It's called non-conformities. Please leave a comment down below if you would like to know what exactly an NC is. So the data is used to evaluate, monitor, and control a process. Now, within our manufacturing plant, we do have a lot of processes, and this is a tool which is used to control a lot of our processes. And this is the firm AIAG. So AIAG is the firm that published a whole manual about SPC, and they use a lot of the SPC within the current day and age. AIAG is Automotive Industry Action Group, and it is being used in the automotive standard for ISO. Now let's look into the history of the SPC. It was developed by a man called William A. Shewart in 1924 at Bell Laboratories. And you obviously, as 1924, you can imagine how old the system is. It was used a lot by the military and the weapons facility. And it did slowly fade out of existence, but that's before the Japanese started using these tools again, and they still use it till today. The whole of Japan is using these tools to make sure that their quality is perfect for the final customer. And that's so important in today's day and age because there's a lot of these products which are being imported from Japan and they are high quality. And the only distinguishing factor amongst products, apart from pricing, is the quality, which has to be kept high. And that's why now America is actually using this method due to the high quality and competitiveness. Now, this is an example of a control chart. You can see here, this is an X bar stroke R chart, which is one of the charts in the SPC. Now you have to distinguish between control limits and specification limits. Control limits are determined by the capability of a process. So you can have an upper control a limit, which is marked by this line over here. And you have this blue line, which is averages of a particular process. This is the center line. This is the mean of all the means, the average. So as you can see here, this process is sort of in control, and this process is around about the mean. So you can say that it is it is much more in order than any other process because it's not surpassed the upper control limit and it's not surpassed the lower control limit. But I will be talking about the UCL and LCL in a future video to do with SPC. So make sure you have subscribed to my channel to find out what exactly are this upper control limits, lower control limits, and the center line. Now, let's go to why should you use an SPC in the current day and age? So manufacturing companies are facing a lot of competition in terms of cost, in terms of prices of raw materials, and it's got a lot to do with quality. And quality is one aspect where the companies will require a quality. The reason being is that a lot of people are now competing on the quality. You can obviously compete on pricing, but if you don't have a quality product, you will not go far with a particular customer because at the end of the day, there will be a lot of defects in your product and the customers will not really be satisfied with that. And that is a lot to do with ISO standards where there's high, really high customer satisfaction levels which are required. So this is a tool which is very important to use. But many companies can control their processes, and that's why they use SPC just to do that. And that's exactly what I've been telling you, that if you control your process, you can ensure that the quality of the output coming is according to your expectations. So please make sure to really understand what these 5 core tools are. And remember what I told you at the beginning of the video. Companies also use Kaizen while producing the product. Now, while you're using SPC, it is a method of Kaizen, and Kaizen is a method of continuous improvement. And this has been developed by the Japanese. It's a very important concept because you're continuously improving your processes, your product, you're correcting your mistakes, you're mistake proofing your processes. And if you do want to know about all these videos, just give me a comment down below and I will be sure to make those videos just for you. And since it's done real time, the quality team can detect errors and prevent it rather than taking a corrective action against it. So there are two types of errors that come about, and I will be showing you those two errors. But you do need to detect them, and there's two ways of detecting these errors. There's either a preventive action or there's a corrective action. Now, in preventive action, you're foreseeing the mistake and then you're taking an action on it. But if you're taking a corrective action, it means the mistake has happened. You're trying to get the root cause analysis done, and then you're trying to gauge how to solve the problem. So how do you use SPC then in that case? So the plant must be monitored in different areas which are producing the most waste. And you can see like in this picture right here, there's a lot of scrap. Now, obviously now, if you have all this scrap, it means that there is something wrong in the process because you can't simply generate this much scrap. So you have to see the different areas which are producing the most waste, and waste is very important because you do have waste like scrap, you have waste of reworks, you have even waste in time in inspecting, that is also waste. And obviously it's not used to measure all the production dimensions because that in itself can lead to time delays, and that is very important and critical when you are estimating time for your customers. So please make sure that this tool, you're not overusing it. And obviously, the best time to catch the errors would be in the design failure mode and effects analysis. Now, I will be posting a video on the DFMEA in a future video. So you make sure you subscribe and make sure that you watch that video, because that is a very important concept in this series. And with that, that is the end of my video for today. Please be sure to catch my video for next week, which goes into the part 2 of the SPC. My name is Sal Vasani, and thank you, friends, for watching this video. Please like, share, leave a comment down below, and make sure you gain the knowledge and use it for you and your company to better your quality of products. And this is Sal Vasani signing out.